Welcome guys, this is the 4-bit breadboard computer with very easy to understand architecture. So my aim is that one can easily understand how computer is working. Mainly it is different that there is a control unit which is based on the decoder IC, that is 74hc4514. This is the 4 to 16 line decoder IC. Okay, this is the 74hc 4514 4 to 16 line decoder IC. We create the circuit on this transparent breadboard. This is the 24 pin IC. Ground is 12 number pin and 24 number pin is VCC. Pin number 1 is a latch enable which latches the data inside the chip. This is the active high pin. A0, A1 are the address line. A2 and A3 also the address line. Pin number 23 is enable pin. This is the active low pin. So we must keep this pin low for enable the chip. 4 address lines decoded into 16 independent address line. Pin number 4 to 11 and pin number 13 to 20 are these outputs, that decoded output, or you can say decoded address line. Let's place this chip on the breadboard and create a circuit to see how it's working. Let's connect the ground and chip enable pin to the ground and VCC and latch enable to the VCC. Let's connect all the LEDs to these Q outputs 0 to 15. Initially we will keep the all address lines to low so that Q0 will give high. A0 is the least significant bit. Address 0 will give us Q0. Address 1 will give us 1, Q1, and so on. Address 15 will give us Q15. You can see it on the screen. 4-bit computer has 2-bit instruction register. So most significant bit, or that is A2 and A3, are connected to instruction register. Output line, that is the Q0 to Q15, are connected to our micro instructions. I will explain that whole thing into the next video. Least significant bit, that is A0 and A1, are connected to the step counter. In our case, that is 7476. Fetch cycle of the computer is independent of instructions. That is, it is not dependent upon any instructions. The counter out, memory address register in, and RAM out, instruction register in, and counter enable is our fetch cycle. Here we have 4 steps. Maximum we have 4 steps: 0 0, 0 1, 1 0, and 1 1. Step 0 0 and 0 1 are nothing but the fetch cycle. Step 1 0 and 1 1 are connected with the instructions of our 4-bit breadboard computer. Further, we can upgrade this control logic adding another 74 4514 in combination with this present chip, or 74 138 3 to 8 line decoder with this chip. We can enlarge our control logic. It means that we can add more instructions to our computer. Right now this computer has very little ability, that very limited ability. We cannot program subtractions and additions into one single program. This is the limitation of this computer. because we have only 4 instructions in our pocket. This breadboard computer is okay for educational purpose, but we can upgrade this to use it in a practical way, in a practical life. We can use it further. This computer takes 4 steps to execute one instruction, maximum 4 steps. I have keep it very simple because one must understand very easily how computer exactly working. Right now this breadboard computer has very limited capability and give us only 4-bit addition and subtraction. Limitation is that we have only 4 instructions in our pocket. Those are lower A, lower B, jump and out. We have 0 to 15 locations and we are now using only 6 locations to perform 9 plus 1 and stored our data and instruction from 0 to 6, location number 0 to 6. 0 instruction is load A, 1 instruction for load B, out instruction is 2 and 3 is our jump instruction. Here we are using 3 for jump instruction. In this program we stored it at the location 5. Now the interesting thing is that we are storing value 5 at the location 6. We are doing this for an infinite loop. Task of the jump instruction is that feeding the value 5, that is the data 5, into the program counter again and again. So we are creating the infinite loop. As soon as we finish the program, we will jump into the infinite loop. Let's see the fetching and execution process of program. Here I am giving total 20 clock pulses. Each instructions will take 4 clock pulses. Load A will take 4 clock pulses, load B will take 4 clock pulses, and out instruction will only take 3 clock pulses. One will do nothing. Jump instructions will take 4 clock pulses and that will go into the infinite loop then after. Step first is program counter out and memory address register in. Step second is RAM out, instruction register in and counter enable. This is the fetch cycle for every instruction. For load A instruction, load B instruction, jump instructions, the execution cycle is counter out, memory address register in, RAM out, and particular that register in. That is the for jump instruction program counter in, and for load A register in, and load B register in will execute. In this situation, the third step is counter out and memory address register in, and the fourth step is the RAM out and that particular register in. I will try to explain in details about this breadboard 4-bit computer, and also I will try to upgrade this computer and try to include more instructions, more data space. I will add stack to this breadboard computer, serial peripheral interface to this breadboard computer, extend this breadboard computer from 4-bit to 8-bit and further. Stay connected with these videos so that you can understand logic behind the computer working. Thanks for watching.